I'm going to work through this review fairly quickly. What I recommend that you do is every time we start a new problem, go ahead and pause the video, work through the problem on your own, and then play it and check your work against my work. For this first problem, we're being asked to factor this expression by grouping. And anytime you see a polynomial with more than 3 terms, you're probably going to be asked to group it. So let's go ahead and start. These first two terms, they both have an x squared in common, so we'll factor out an x squared. That's going to leave behind a 2x minus 1. If you look at these second two terms, they both have a 2. We can factor a 2 out, and that's going to leave behind a 2x minus 1. Now we see that between these two terms, they both have a 2x minus 1. They both have that factor in common. So basically, we're just going to factor that out. So we'll have 2x minus 1. Make sure you keep that in parentheses. And we'll be leaving behind an x squared plus 2. We're asked to factor this completely as well. So I'm just going to go ahead, since this is a trinomial, I like to write my parentheses out first. I know that these first two terms, when I multiply them together, they need to be 2x squared. So this is going to be 2x and x. And these two terms, when I multiply those two together, those need to give me 5. So I'm going to write in a 1 and a 5. I'm going to put my plus here and my minus here. And what you'll want to do is, especially when you're taking a test, is just multiply it together, and it should give you the original polynomial. So this is my answer, but I'm just going to multiply everything together and make sure I got everything right. 2x times x is 2x squared. 2x times 5 is 10x. The inside is negative x, negative 1x. The last is negative 5. Combine everything, 2x squared plus 9x minus 5, and that checks. So my answer is my factored form, but I just multiplied everything together just to make sure that it checked. This polynomial expression is the difference of cubes. So that takes on the form a cubed minus b cubed, which, if you factor it, is a minus b times a squared plus ab plus b squared. In this case, what is it that's being cubed? Well, the x is being cubed minus 5y. That's what's being cubed. So in this instance, this is my a and this is my b. So everywhere I see an a, I'm going to substitute in an x, and everywhere I see a b, I'm going to substitute in a 5y. So using my factoring formula here, or template, I'm going to have x minus 5y, and then over here I'm going to have a squared. Well, what did I say my a was? My a was x, so that's going to be x squared, plus a times b. Well, a is x, b is 5y. If I multiply those two together, I get 5xy plus b squared. b is 5y, so I'm going to square that, and that's going to give me 25y squared. The domain of a rational function is all real numbers except those values that make your denominator 0. If it makes your denominator 0, you can't divide by a 0, or you can't have 0 in the denominator. So what we really need to do is we just need to look at the denominator, x squared plus 5x plus 4, and we're going to factor this guy. So x, 1, 4, plus. Well, what's going to make this first factor a 0? Well, x would have to be negative 1. What's going to make the second factor 0? Well, x would be negative 4. So the question is, what's the domain of this function? What can x be equal to? Well, x can be equal to any real number except it can't be equal to -1 and it can't be equal to -4. Anytime you see an expression that involves a lot of polynomials, your best bet is to go ahead and factor those polynomials. So we'll go ahead and we'll factor this. If we factor the numerator over here, we're going to get 2x and x, and then we're going to get, I'm going to put a 3 here and a 1 here, and I'm going to put plus in, or plus in front of the, and a, oh, I'm sorry, this is going to be 3 and 2. So I'm going to put a, let's fix that a little bit. Sorry. So 2x times x is 2x squared. 3 times 2 is 6. I'm gonna place a minus or a plus here and a minus here. Then I'm going to go through. I'm going to factor the denominator of this polynomial. That's going to be x and x, 2, 4. I'm going to place a plus here and a minus here. Remember, multiply it back together again to make sure that this product gives you the original polynomial. Okay, now we're going to take and divide this by, let's go ahead and factor this guy up here. So this is going to be x and x, 1, 4 plus minus. Down below, we're going to have 2x and x, 3 and 1, and I'm going to put a minus here and a plus here. Almost done. Notice that we have division here. Well, division is the same as multiplying by the reciprocal, so we're going to have 2x minus 3, x plus 2, all of this over, x plus 2, x minus 4, times, and then we're going to flip. We're going to put the denominator up in the numerator. We're going to put the numerator down in the denominator. And then the best part, funnest part, is just going through and just simplifying everything. So the x plus 2's are going to cancel. The x plus 1's are going to cancel. And what do I have left? Well, in the numerator, I have 2x minus 3 squared. I have 2 of those. And in the denominator, I have x minus 4, 2 of those. So that's going to be squared. Let's go through and let's subtract these two expressions. I'm going to go ahead and factor my numerator, so that's going to be 2, and then in parentheses I have x squared minus 8, and then my denominator is going to be x minus 2 times x plus 2. That's the difference of squares. My second fraction is going to be x plus 4 over x minus 2. My common denominator here is, oops, sorry, this is supposed to be a minus. So my common denominator here is x minus 2, x plus 2. I am missing an x plus 2, so I'm going to multiply the denominator by x plus 2, and I'm going to multiply the numerator by x plus 2. I need to adding or subtracting fractions, you've got to have a common denominator. So if I go through and I do my math, I'm going to get 2x squared minus 16. I guess I really didn't need to factor that to begin with. And then I'm going to get minus, and I'm going to go through and FOIL this whole thing. So minus x squared plus 2x plus 4x plus 8. That's going to come together to give me a 6x. So if I go through and I just simplify this numerator, I'm going to get 2x squared minus 16. I'm going to take this minus sign, I'm going to distribute it across everything. So this is going to be minus x squared minus 6x minus 8. Now I'm just going to go through and combine my like terms. 2x squared minus x squared is x squared. I got a minus a 6x. Minus 16 and minus 8 is minus 24. And if I... oh, I'm sorry, what am I doing here? I got minus 16. Is that a plus 8? Nope, that's a minus 8. X plus 2. Okay. That's going to be all over my common denominator. Let's not forget that common denominator. And you can leave it either in factored form or you can write it out. You can multiply that out together as well. I want to simplify this complex rational expression. So I'm going to look at all my denominators. All of these denominators, I'm going to ask myself, well, what's the least common denominator? Well, there's a 3, an a, and a b. So basically, I'm going to take this numerator and I'm going to multiply it by 3ab. And I'm going to take this denominator and I'm going to multiply that by 3ab. Now remember, we're going to be distributing this, okay? So if I take this and multiply it to that first fraction, notice that the 3 in the a is going to simplify with the 3 in the a of the factor that I'm multiplying by. So that's just going to leave me with b. And when I take and I multiply that to the second, the 3 and the b will cancel. So that's just going to leave me with a. And then over here, if I distribute here, the b's are going to simplify. So that's going to leave me with 3a squared. And if I take and multiply this to that second fraction, the a's are going to cancel. So that's going to be minus 3b squared. Okay, well, there's still a little more work to do on this problem. Let's see if we can do that. B minus a, I'm going to factor out a 3, leave a 3 behind. That's going to be a squared minus b squared. Now I'm going to take and factor that difference of squares. So this is going to be 3, and in the denominator I'm going to have a minus b and a plus b. Difference of squares. Notice, guys, that this factor here and this factor here, they're almost identical, except they're opposites of each other. The b is positive in the numerator, the a is negative. Down below, the a is positive and the b is negative. So what I'm going to do is I'm going to factor out a negative 1. Okay, factor out a negative. That's going to make this a negative. That's going to make this b positive. So now both the factor in the denominator and in the numerator, they're identical. So this is going to simplify and leave me with 1. And this guy right here is going to simplify. So my final answer is going to be 1 over negative 3, and then in parentheses, a plus b. I have a rational equation here. Let me go through and let's factor that rational expression on the right side. That's going to help me determine what the denominator is. So this is going to be 2, and down here I'm going to have x and 2 and 4 and minus. When I'm trying to solve equations, I like to get rid of my fractions. And if you can identify what the least common denominator is, then multiply both sides by that. So for example, here I'm going to multiply the right side by x minus 2 and x minus 4. That's the least common denominator. And I'm going to do the same thing over here. I'm going to multiply this whole thing by x minus 2 and x minus 4. I kind of ran out of room there. So when I multiply this first fraction by x minus 2, x minus 4, well, what happens to those x minus 4s? They cancel, they simplify, and that leaves me with x minus 2. Okay? when I take and I multiply that by the second fraction, well, the x minus 2's are going to simplify. So that's going to leave me with x times x minus 4. And then over here on the right, well, all of this stuff is going to simplify. I'm going to get rid of both of those factors. And so all I'm left with here is just a 2. Well, if I just go through and multiply, combine like terms, I'm going to get x squared minus 3x, set this guy equal to 0, so minus 4 is equal to 0. Now I'm going to factor. So factoring is going to give me x, 1, 4. That's going to be a minus and a plus. So here we're going to have x is equal to negative 1 and x is equal to 4. Now you need to be careful here because in the original problem, if you look at this original problem, you'll notice that x cannot equal 4 because that's going to make your denominator 0. So you have to, x can't be 4 and x cannot equal 2. So those are two solutions that you cannot have, and in this instance we ended up with this 4. So the only solution here is x is equal to negative 1. When you're dividing polynomials, one technique that we talked about in this class is using synthetic division. Well, synthetic division, what it does, it requires that you identify the 0 of the factor that you're dividing by. So we're dividing by x plus 4. Well, what is the 0? What's the number that I would have to substitute in for x to make that a 0? Well, that number is negative 4. So we're going to have negative 4, and we're going to take and divide that into, we're going to get all of our coefficients here. So 2, 6, negative 7, 9, and 11. And this is how synthetic division works. So we're just taking all of the coefficients and just bringing them down. And we drop down that first coefficient. Well, negative 4 times 2 is negative 8. We'll add those up. That's going to leave me with negative 2. Negative 4 times negative 2 is 8. Add that up. That's going to leave me with a 1. Negative 4 times 1 is negative 4. Add that up. That's going to leave me with a 5. And then negative 4 times 5 is negative 20. Add that up, and you get negative 9. Well, what does that represent? That is your quotient. So we started out with a polynomial. The first term was 2x to the 4th. Well, what we're left with is 2x to the 3rd minus 2x squared plus x plus 5, and this guy right here, that's your remainder, okay? So that's going to be plus a negative 9 over, well, what were we dividing by? We were dividing by x plus 4. So that is the quotient. If you take this polynomial here and divide it by this polynomial here, this is what you'll have. One of the properties that we learn when we're dealing with radicals is you can take and you can break this up into 169, the square root of 169 over the square root of 25. Well, the square root of 169 is 13, and the square root of 25 is 5. Here we're taking the cubed root, so basically what we're doing, I'm going to sneeze here, guys. Oh, okay. So what we're doing here is we're looking for factors that appear 3 times. So negative 125, that's the same thing as saying negative 5 times negative 5 times negative 5. Negative 5 times negative 5 is 25. 25 times negative 5 is negative 125. Since we're taking the cubed root, we're looking for factors that appear 3 times. So the cubed root of negative 125 is just negative 5. No radical or anything, it's just negative 5. All right, on this particular problem, we want to simplify this. So everything inside the parentheses is being raised to the 3/2 power. So the 9 is being raised to the 3/2 power. X to the 6th, that's being raised to the 3/2 power. And y to the 4th is being raised to the 3/2 power. Okay, well, 9 to the 3/2, if we write that in radical notation, that's the square root of 9 raised to the 3rd power. The denominator is your root, and the numerator is your power. So this is the square root of 9 raised to the 3rd power. And just following our rules here, we're just going to take and we're going to multiply those exponents together. So that's going to give me 6 times 3 is 18, divided by 2 is 9. So that's going to give me x to the 9th. And then over here, I'm going to do the same thing over there. 4 times 3 is 12. 12 divided by 2 is 6. So that's y to the 6th. Let's take a look at this guy right over here. The square root of 9 is 3. Well, we still need to raise that to the 3rd power. So our final answer is going to be 3 times 3 times 3, which is 27, x to the 9th, y to the 6th. Alrighty, let's take this problem here. We want to simplify it, but I'm going to go ahead and let's just take what's inside the brackets or inside the parentheses here, and let's just kind of clean this up a little bit. The 16 is fine. Let's leave that alone. A cubed, that's fine. This a to the negative 1 down here, let's bring that up to the numerator. That's going to make that positive 1. B to the 6th, let's leave that alone. And then we're going to bring this b to the negative 2, we're going to bring that down to the denominator. That's going to be b squared. So that's just what's inside the parentheses. All of this is being raised to the 1/4 power. Well, let's clean this up some more. So this is going to be 16 a to the 4th over b to the 8th, just adding our exponent. Remember, what we're going to be doing here is we're going to be taking the 4th root of all of this. So everything inside the parentheses is being raised to the 1/4 power. So the 16th is being raised to the 1/4 power. A to the 4th is being raised to the 1/4 power. B to the 8th, that's being raised to the 1/4 power. Oops. So the 4th root of 16 is 2. If I multiply those two together, 4 times 1/4 is 1, so that's going to be A. And then here, 8 times 1/4, if I multiply those two together, I get 2. So this is just b squared. That's your final answer, 2a over b squared. Here again, we're taking the cubed root of this expression, so we're taking the cubed root, and if you just want, you can, this negative 125 is negative 5 times negative 5 times negative 5. You can just write it all out. We've got 5 x's, we've got 8 y's, 1, 2, 3, 4, 5, 6, 7, 8. We're taking the cubed root, so anything that appears 3 times, we're going to take the 3rd root of that. Okay? So that's going to be a y, that's going to be a y, that's going to be an x. This right here is going to be a negative 5. So when we take the cubed root of all of this, we're going to be left with negative 5 x, y times y, or y squared, and then we're going to leave behind 2 x's, x squared, and 2 y's, y squared. That'll be your final answer. Alright, let's go ahead and simplify this expression. For 12 can be written as 4 times 3, a squared minus 3. 75 can be written as 25 times 3, a squared minus, and we'll just leave this guy alone. Oops. So this is going to be 9a. And now we can just go through and simplify this. We know that the square root of 4 is 2. A squared is a. Square root of 25 is 5. Square root of a squared is a. And the square root of 9 is 3. Alright, so we know that now that when we take the square root of that, 2 times 4, that's going to be 8a. We're going to leave behind square root of 3. Then we're going to have minus 15a. We leave behind a 3. And then finally we're going to have minus 18. And we're going to leave behind the square root of a. These guys here, those are like terms. So 8a minus 15a, that's negative 7a. If we add those together, square root 3 minus 18 times the square root of a. We want to rationalize this fraction, so I'm going to multiply the denominator by the conjugate, 4 plus the square root of 3. Multiply the numerator. You've got to multiply the numerator and the denominator by the same thing. So if we distribute, we'll have 2 times 4 is 8 plus 2 square root 3. Down below, we're going to have to FOIL. So 4 times 4 is 16. 4 times the square root of 3 is 4 square root 3. Negative square root 3 times 4, that's going to be minus 4 square root 3. And then a negative square root 3 times square root 3, that's going to be square root of 9, or minus 3. And that's exactly what we want to see happen, is we want to see these two terms right here, we want to see those cancel out. So what we're left with is 8 plus 2 square root 3. 16 minus 3 is 13. And if you want, you can kind of split this up into two. Your common denominator is 13, so you can write this as 8 over 13 plus 2 square root 3 over 13. Here we have a radical equation with a radical in it. To get rid of the square root sign, I'm going to square both sides. So I'm going to square the left side and the right side. And if I do that, squaring has the effect of getting rid of that square root sign. So I'm left with 3x squared plus 10x and 25 on the right side. Now if I just take and set this thing equal to 0, I'm going to have, let's go through and factor this, 3x, x, I'm going to try 5 and 5, minus here and plus here. Let's see, is that right? Nope, other way around, sorry. I want, see, I have to check those, because, so I want my plus here and my minus here. Alright, now it's factored correctly. Alright, so if those are the factors, then here the 0 would have to be 5/3, and here the 0 would have to be negative 5. So your solution would be 5/3 and negative 5. Let's go ahead and distribute this. So if we take and multiply these two together, we're going to get 10i. If we take and multiply these two together, bring down your minus I, 2i, and 4i is 8i squared. Well, we know that the value of I squared is negative 1. So what we have is 10i, and then a minus 8 times a negative 1 is going to leave us with plus 8. So 10i plus 8. When you're subtracting 8 times negative 1, that's going to leave you with plus 8. Again, we want to rationalize the denominator, so we're going to do the conjugate with this. The conjugate of 2 plus 3i is 2 minus 3i. You got to multiply the top and the bottom by the same thing. So when we go through and multiply, our numerator is going to be 14i minus 21i squared. And then down below, if we FOIL it, 2 times 2 is 4. The outside is negative 3i. The outside is negative 6i. The inside is positive 6i. Those are going to cancel each other out. That's why we multiply by the conjugate. Minus plus 3i and minus 3i is going to be minus 9i squared. Now we know that I squared is negative 1, so up in the numerator we're going to have 14i plus 21 minus 21 and a negative 1. Multiplying those two together is going to give us a plus 21. And then down below, you're going to have 4 plus 9. Okay, I squared is negative 1. Negative 9 times negative 1 is positive 9. So this is going to be 13. If you want to split this up into two fractions, you're going to have, this is going to be 14i over 13 plus 21 over 13. Or if you want to be exact in terms of the format for writing this, we would write this as 21 over 13 plus 14 over 13i. That's written in the correct form. Either one of them is fine. We want to solve this equation by using the square root both sides. So I'm going to take the square root of the left side, and I'm going to take the square root of the right side. Now remember, when you take the square root, what you're doing is you're eliminating one of the possible solutions. So we have to do the plus and minus of that. So the square root of x minus 2 squared is just going to be x minus 2 is equal to plus or minus the square root of 5. Now we're going to add 2 to both sides, and we're going to have x is equal to 2 plus or minus the square root of 5. You can represent your answer that way, or you can break it up. 2 plus the square root of 5 and 2 minus the square root of 5. Those are your two solutions. Anytime you're solving a quadratic equation, always look to see if there's a common factor, and in this case there is. Factor out of 4, that's going to leave you with x squared minus 3x plus 1 equals 0, and then if you divide both sides of this equation by 4, you're just left with x squared minus 3x plus 1 is equal to 0. That way, instead of using these really large numbers, we're just going to use these small numbers. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So let's go ahead and let's plug those numbers in. Negative b, well, b is negative 3, so that's going to be a negative 3 plus or minus negative 3 squared minus 4. A is 1. C is 1. Okay. And all of this is going to be over 2a, or 2 times 1. Well, the opposite of negative 3 is 3, plus or minus. Negative 3 squared is 9, minus 4. All of that over 2. And then finally, we're going to have 3 plus or minus the square root of 5 over 2. Again, if you want to split this up into two separate fractions, you're going to have 3 plus the square root of 5 over 2 and 3 minus the square root of 5 over 2. Those are going to be your two solutions. All right, so this equation here, it's already given to us in standard form for a quadratic equation. We can rewrite this as x minus a negative 5 squared minus 2. So when it's written in this form, x minus a squared plus b, the vertex of your parabola is a and b. That's your vertex. Okay? So looking at this equation, what's the number that follows the minus sign here? Well, the number is -5, and this guy right here, that's your b, so that's going to be -2. So -5, -2, that is the vertex of your parabola. Now, if you wanted to, if you can't remember to get it in that form, or if you don't see it in that form, you can go ahead and multiply all of this out. You can take this guy right here and you can FOIL it out. X plus 5 squared is x squared plus 10x plus 25 minus 2, or x squared plus 10x minus 23. And then you can, there's that little formula that we used, -b over 2a. Well, in this case, b is 10, so -b would be -10, and 2a would be 2 times 1, so that's going to be -10 divided by 2, which is -5. And then if you take and you plug -5 into the original problem, you're going to get -2. So you're going to end up with the same answer. -5, -2 will be the vertex of the parabola. When it comes to exponents and logarithms, here's the thing that you need to remember. Just remember the definition of what a logarithm is. If you have b to the x is equal to a, you can rewrite this as log base b of a equals x. In other words, these two statements, they mean the same thing. They're just written differently. This is written as an exponent, this is written as a logarithm. So you just need to be able to kind of just translate them back and forth. If I give you the logarithm, you should be able to take that and translate it back as an exponent. So over here, what's the base? Well, the base, log base 27 of 9 is equal to 2/3. Base, and this is right here, is this is your exponent. 2/3 is your exponent. So log base 27 of 9 is equal to 2/3. Here we have a logarithm, and we're going to go ahead and we're going to write this as an exponent. Well, our base is 10, so 10, -3 is my exponent. 10 to the -3 is equal to 0.001. One way to solve an exponential equation is to get it so that you have equivalent parts of the equation. So on the left side you have 2 raised to the x power, and 16, you can rewrite that as 2 to the 4th power. 2 times 2 times 2 times 2 is 16. Well, notice that the bases are the same. They're both 2. Therefore, those exponents have to be the same. X has to equal 4. That's your solution. If we try it again, we're going to have 3 raised to the 1 plus 2x, and let's rewrite 27. So 27 would be 3 to the 3rd power. Again, notice that the bases are the same. If the bases are the same, then those exponents have to be the same as well. So we have 1 plus 2x is equal to 3. Now solving for x, we get 2x is equal to 2. Divide both sides by 2, and you get x is equal to 1. Anytime you're given a logarithm and you don't know how to solve it, try rewriting it as an exponent. My base is 5. x is my exponent, so 5 to the x is equal to 125. Well, I can rewrite 125 as 5 to the third power, so therefore x has to equal 3. X is equal to 3. Using the definition of a logarithm, I'm going to rewrite this. My base is 4. 4 to the negative 2 is equal to x. So you could write it like that. Another way to write 4 to the negative 2 is 1 over 4 squared. Okay? And 1 over 4 squared is 1 over 16. So your answer, you can either write it as 4 to the negative 2. When we normally don't like to write answers using negative exponents, so we'll use the property that allows us to convert this into 1 over 16. I don't know if you remember, but there's that one property that says log base b of x, log base b of x plus log base b of y. Well, we can combine those two logarithms into a single logarithm, log base b of x times y. And that's the property that we're going to use here. So here we're going to have log base 2 of 5 plus 2x, and since we're subtracting here, well, that's the same thing as dividing, so this is going to be 4 minus x is equal to 3. Okay, so the log of the sum is equal, I'm sorry, the sum of the logs is equal to the log of the sum, and the difference of the logs is equal to the log of the quotient. All right, now I'm going to use my definition of a logarithm. 2 raised to the third power is equal to 5 plus 2x over 4 minus x, which is going to be 8. And now I can just go through, I'm going to multiply both sides of the equation by 4 minus x, and if I do that, I'm going to have 32 minus 8x is equal to 5 plus 2x, and I'm going to go ahead and move that the x's to the right side, so that's going to be 10x. I'm going to subtract 5 from both sides, so that's going to give me 27, and if I divide both sides by 10, I'm going to get x is equal to 2.7. I'm going to use all of my logarithmic properties here, so I'm going to rewrite this as log base b of 2a squared minus log base b of c cubed. This guy right here, I can break that up. That's going to be log base b of 2 plus log base b of a squared minus log base b of c cubed, and then all of these little exponents, there's that little property that allows us to bring these exponents down in front, so we end up with log base b of 2 plus 2 log base b of a minus 3 log base b of c. In other words, we were able to take this this expression here and split it up into separate logarithms using those properties. Using those same properties, I'm going to go ahead and rewrite this as log base m of x raised to the 4th power minus log base m of y. Since we're subtracting, I'm going to combine this into a single logarithm where we're dividing. So log base m of x to the 4th over y. So one of the last properties that we learned in this course is that you can take any logarithm of any base and you can split it up into the quotient of logarithms that you're more comfortable with. So log base 2 of 15, we can rewrite that as log base 10 of 15 over log base 10 of 2. Or, if you wanted to, you could have done natural log of 15 over the natural log of 2, log base e. That's the natural log. It doesn't matter if you type log base 10 into your calculator or if you type in log base e or natural log. You're going to end up, either way, you're going to end up with approximately 3.9. This one is going to be approximately 3.9. So in your calculator doesn't have base 2 on it, but it does have base 10, and it does have natural log, or base e. So if you're given a logarithm in a base other than 10 or e, you can rewrite it using this property, and we end up with 3.9 as our final answer. So we just went through and we just solved 32 problems. Well, there happens to be 32 problems on the final exam, and the 32 that we just did in this review are very similar to the 32 that are on the final exam. So I would, if I were you, I would go through and watch this video, work these problems, and also spend some time going over that other review that I gave you as well. Both of those cover the final exam pretty well. You'll notice that this video took about 45 minutes to go through all of these problems. You're going to have 2 hours. So I would recommend that you study, take your time, and all you need to do is just on this final, all you need to do is just make 60% on this final exam, and then your grade will end up being whatever grade is calculated in the grade book. But you got to score at least 60% to pass the class. Guys, I wish you the best. Good luck. If you have any questions or if you need any help with anything, just let me know.